In this video, we solve problem 6.2.8 from Nagle's Fundamentals of Differential Equations, 7th edition. We're asked to find a general solution for the differential equation with x as the independent variable. We have a third order differential equation here, and it has constant coefficients and it's homogeneous. So we're going to let let y equal e to the mx. Because derivatives of exponentials are exponentials, and for the right exponentials, all these exponentials will cancel out and we'll get 0. In order to find out which ones, we need to find the values of m that cause this to be a solution to that equation. So to find the values of m, we take the first, second, and third derivative, since it's a third order equation, and then we substitute into the differential equation. That's going to lead to an algebraic equation involving m that must be satisfied if y equals e to the mx is a solution to this equation. That's the plan. So let's start by letting y equal e to the mx. Compute the first derivative. Compute the second derivative. You're multiplying by an extra m every time because of the chain rule. Derivative of e to some power is e to that power, mx, times the derivative of the inside. And the derivative of a constant times x is just the constant. That's the m. So then we'll substitute into the differential equation, and that'll lead to this algebraic equation. Y triple prime is this. We're adding 6 times y double prime and subtracting 15 times y prime and adding 8 times y. And we'll factor out the e to the mx. And e to the mx is never 0. So the only way this product is 0 is if the polynomial is 0. Now from here, you can factor. If it's easily factored by grouping, I would suggest factoring by grouping. This time it's not, so we should use possible rational roots to get a list of possible values of m that may make this equation 0, and then we can substitute some of those values and see if we can't get a root out of it. Once we have a root, we have a corresponding factor, and we can divide out the factor. This is called the characteristic equation of the differential equation. So it's not easily recognizable as factorable, so let's list our possible rational roots. Now the possible rational roots come from taking the factors of the constant term, in this case 8, and then dividing by the factors of the leading coefficient. The leading coefficient is 1. Factors of 8 include plus and minus 1 and plus and minus 8, plus and minus 2 and plus and minus 4. And we'll take all of those and divide by plus and minus 1. So our possible rational roots include 1, 2, 4, and 8, or -1, -2, -4, and -8. Okay, so the question becomes, which values on this list do you think will actually give us a 0 over here? Well, I know if I plug in just m equals 1, I'd have 1 plus 6 is 7, 7 plus 8 is 15, and 15 minus 15 is 0. So I think m equals 1 is going to work. So let's say try m equals 1. I've sort of already done the arithmetic in my head. So you have 1 plus 6 minus 15 plus 8. 7 and 8 is 15. 15 minus 15 is 0. So that means m equals 1 is a root. And that means m minus 1 is a factor. So what we did was we were trying values of m from our list. And our goal is to find a root. And again, a root is a value of m that will cause the polynomial to be 0. We can also call these zeros of the polynomial. So that is that. So we had m equals 1 is a root of the polynomial. That means that m minus 1 is a factor. And if m minus 1 is a factor, that means that m cubed plus 6m squared minus 15m plus 8 is equal to m minus 1 times some polynomial q. And that means that q can be found by just taking this equation and dividing by m minus 1. Okay, so we need to find q by doing this division. And I will use synthetic division for this. So we set this factor equal to 0 and solve for m. We get m equals 1. It's the same as the root that's corresponding to that factor if the leading coefficient is 1. And then we list the coefficients of this polynomial over here. So we'll have a 1, a 6, a negative 15, and an 8. Bring the 1 down, multiply, and add. Multiply, and add. Multiply, and add. And then these are the coefficients of the polynomial q. Notice that we get a 0 here. That should be a 0 because that's the remainder, and we should have a remainder of 0 when we take this and divide by this, because this is divisible by m minus 1, and we know this is divisible by m minus 1 because m equals 1 is a root. So if this is a root, that should be a 0. That number's a root, that should be a 0. Okay, so q is the quadratic polynomial, and we know it's quadratic because we're taking this cubic polynomial and we're dividing by a linear polynomial. So the exponent goes down by 1, so it's going to be quadratic. When we're done, it's going to start with an m squared, and this is the coefficient of that m squared. So we'll have 1m squared plus 7m minus 8 as our q. And that means our cubic polynomial that we're starting with, our characteristic polynomial, is m minus 1 times q. And that's equal to 0. So the question becomes, does this factor? Can I find two numbers that give me a product of negative 8 that add to 7? Well, since the product is negative, that means they're going to have opposite signs. So what I really need is two numbers that multiply to give me 8 that have a difference of 7. Well, 1 and 8 will work if the 1 is negative and the 8 is positive. Negative 1 plus 8 is positive 7. Negative 1 times 8 is negative 8. So this is m minus 1. I'm just bringing that down times this guy. And since this is a negative 1 and that's an 8, I should have m minus 1 here and an m plus 8 there. So we have factored our characteristic polynomial. And once you do that, then you'll have your m1, m2, and m3. Now notice we've got an m plus or m minus 1 twice, so that's m minus 1 squared. So we have a repeated root. This one tells us that m1 and m2 both have to be 1 in order for that factor to be 0. If this times this is 0, this factor is 0 when m is equal to negative 8. So if m is equal to negative 8, we get a 0 for this product. If m is equal to 1, we get a 0 for this product. So those are our m values. And then once you find the m's, you want to find the corresponding solutions y1, y2, and y3. Well, for our repeated root, the first solution is e to the m1x. So in this case, e to the x. The second solution comes from reduction of order. If this is a solution, it turns out that x times e to the x is also a solution. And then this is m1 and m2. Our third m is negative 8. So y3 is e to the negative 8x. And then the general solution is y equals c1y1 plus c2y2 plus c3y3, which equals c1 e to the x plus c2 x e to the x plus c3 e to the negative 8x. And that will work on negative infinity to infinity. That's our general solution. Now, one thing that I've noticed when students have repeated roots is sometimes they will just write m1 equals 1 and m2 equals -8. And then they'll have this as the general solution, this plus this, and they'll have this one will be missing. One way that you can avoid that is to look at the differential equation that you started with. This is third order. That means I need 3 values of m. So if I have 2 values of m here, something is wrong. Either I left off a factor somewhere earlier in my computation, or I forgot to count this as a repeated root. Since that's squared, I've got 2 values of m that are associated with that. And if I have 2 m values that are associated with that happen to be the same value, then we still get 2 linearly independent solutions for that repeated root. So you want to keep that in mind. And again, we just let y equal e to the mx. We take derivatives multiple times. We substitute into the equation. We solve the equation using possible rational roots to get a first factor. Maybe use synthetic division to divide out that factor. And then if what's left is quadratic, we can just factor from there. Sometimes we use the quadratic formula or completing the square to factor the quadratic if it doesn't factor easily. And then we use that to find the values of m. And once we have the m's, we find the y's. And then once we have the y's, we just take those y's, multiply them by constants, and add them together to get the general solution.